First, we are expanding logarithms. Everything that's inside the logarithm needs to get its own log. So we have log of 3, we have log of x to the 4th, we have log of y squared. The 3 and the x to the 4th were on the top, so those two logs need to be positive. Y squared was on the bottom, so that log needs to be negative because division inside the log is the same as subtraction between the logs. Then the last thing is that these exponents need to move and become coefficients. So our answer should be log of 3 plus 4 times the log of x minus 2 times the log of y. Now, a formatting hint. You need to put parentheses around the terms inside your logarithm. You either can use this keyboard and punch in log, notice it puts parentheses in there for you, or if you type log, see how it straightens out? You just need to put the parentheses in there so that it will count this as correct. So really our correct answer is like this, with parentheses around the stuff that's inside each log. So log of 3, oops, I don't want to punch the 3 in there, I need to punch it in here. Log of 3, move outside the parentheses, plus 4, honestly I would just use this button because that's going to make it easier for you. 4 times the log of x, move outside of the parentheses, minus 2 log y. And if you want to check that just to be sure, yes, that is correct. Notice it needs those parentheses in order to count it as correct. Now you should be able to, on this problem, if you wanted to, in between 4 and log x, you should be able to put a times dot if you want to. That should also check as correct, and it does. So whether you put the times dot or just put 4 log x, it should be good either way. All right, next question. Condense the logarithms. This time we're going backwards. So that 3 in front is going to become an exponent on the x, and the 2 in front is going to become an exponent on the x plus 5. Because the x to the 3rd is in a positive log, x to the 3rd is going to be on the top, and x plus 5 squared is going to be on the bottom. So again, punch the log button, and then I would do the fraction button right away and do x to the 3rd. Remember that you can use your keyboard and do Shift 6 to get the caret to get the exponent, or let me type in x plus 5. Oops. Or you can use this button for exponents here on the keyboard or on the screen as well. Solve the equation, round to 2 decimal places if necessary. Your first step is going to be to get the e to the 3x by itself. So you need to subtract 14 on both sides. That'd be 232. And then divide by 4. So we have e to the 3x equals 8. We're now stuck, and when you're stuck, you change forms. 1, 2, 3, woo! So log base e of 8 equals 3x. Log base e is the same as ln. So this thing says ln of 8 equals 3x. ln is a button on your calculator, so you punch the ln button and the 8. ln of 8, the natural log of 8, is the decimal 2.0. It says round to 2 decimal places, so I'm going to do 2.08. And then divide both sides by 3. To finish this off, our answer is 0.693, but it says to 2 decimal places, so 0.69. Now this will accept, because it's a number field, it will accept 0.69, or if you just type in 0.69, it will count that as correct as well. So whichever version of that you prefer to use, 0.69 or just 0.69, it will count that as correct. On this next one, again, we need to get the thing that's raised to the exponent by itself. So the first thing that we're going to do is add 5 to both sides. 18 plus 5 is 23. That looks like negative 23. Then we need to do the log ride. 1, 2, 3, woo! Log base 7 of 23 equals x plus 3. Log base 7 of 23, we evaluate that by doing log button 23 divided by log button 7. Or if you have one of the fancy calculators, you can do alpha window 5 to get that log base thing, but a lot of you don't. So just using the log button and the change of base formula is fine. So log button 23, close your parentheses, divided by log button 7. You should get the decimal 1.61. And then to finish solving this, you would subtract 3 on both sides. So 1.61 minus 3 gives us negative 1.39. Negative 1.39. Now we're going to start solving logarithmic equations. If there was something in front of the log, you would need to divide both sides by that. If there was something after the log, like after the parentheses, you would need to add or subtract that first. But this log is by itself, so our next step is the log ride, change forms. Woo! This is 5 to the third equals 5x plus 3. So 5 is the first number the log ride touches, then you raise it to the next number, the third, equals all of this stuff at the end. 5 to the third is something that you can do in your calculator. 5 to the third is 125. Then this is a two-step equation. You subtract 3 on both sides. 125 minus 3 is 122. And yes, this is going to end up giving us a decimal, so then we divide by 5 to get 24.4. So x equals 24.4. Now, if it's a log problem, you should check to make sure that you're not going to end up with a negative inside the log. The exponential equations, you don't need to check. The logarithmic equations, you do need to check. If I do 5 times a positive number and then plus something, it's not going to give me a negative, so my answer is totally fine. Okay, here's an example where the log is not by itself, so you're going to have to do a little bit of work before you change forms. So the first thing we need to do is divide both sides by 3. 18 divided by 3 is 6. Now, what base is ln? ln is the same as log base e. So you could take the time to rewrite this log base e of 6x equals 6. But I know some of you don't want to take the time to rewrite it. So if you just want to stick a little e in the base to remind yourself, you're not really adding that to the equation. You're just reminding yourself that ln means base e. And then we do the log ride. Woo! E to the 6th equals 6x. E is right above your ln button. So second ln button gets you your e. Raise that to the 6th, and we get the decimal 403.43. And then to finish this example, we divide both sides by 6. And we get 67.24. Again, you should check to make sure that this isn't going to create a negative inside the log. So 6 times a positive number is still going to be positive, so everything is going to be fine. The big thing is you can't have a negative number inside your logarithm. Okay, this one we first need to condense. So when we condense, this becomes the log base 2 of x times x minus 6 equals 4. Then we do the log ride. Woo! That is 2 to the 4th equals all of this, x times x minus 6. 2 to the 4th, according to my calculator, is 16, and this is x squared minus 6x. When you have x squared and x, you need to get 0 on one side so that you can factor and solve. So I will subtract 16 on both sides. And then we're going to need to factor this thing. We are looking for two numbers that multiply to give us negative 16 and add up to negative 6. So think about 16. We've got 1 times 16, 2 times 8, and 4 times 4. If I did 2 and negative 8, 2 plus negative 8 is negative 6. So this is x plus 2, x minus 8, which means our solutions are negative 2, because negative 2 plus 2 would give us 0, and positive 8, because positive 8 minus 8 would give us 0. Check these back in the original problem. I don't know if you can see where I'm clicking, but back in this original problem, log base 2 of x plus log base 2 of x minus 6. If I put negative 2 in there, so that very first part, I'm just going to rewrite it really quick. Log base 2 of x plus log base 2 of x minus 6. If I put negative 2 right in there, I've got negative inside that logarithm. That's bad. So that answer is extraneous, in which case, look here, the extraneous solution is negative 2 is our extraneous solution. So drag and drop that in there. If I check 8, 8 in here is positive, and 8 minus 6 is positive, so 8 is fine. X equals 8 is my solution. And our final problem, ln of 8x plus 12 equals ln of 2x. The ln's are the same, so that means that the stuff must be the same. So 8x plus 12 must equal 2x. All right, I would subtract 8x on both sides. So 12 equals negative 6x. Divide by negative 6, and I get x equals negative 2. So I'm tempted to just say x equals negative 2. But the directions say check for extraneous solutions, and this is a log problem, and you always need to check your solutions when you have log problems. So if I put negative 2 in, I'm just going to pick right here. A positive 2 times a negative 2 is going to result in a negative number. I don't even care what the number is. I mean, the number is negative 4. 2 times negative 2 is negative 4. But I don't really care what that number is. I just care that this is a positive number. I'm trying to plug in a negative number, and if I multiply a positive times a negative, it is going to be negative, and that's bad. You can try it over here as well. 8 times a negative, well, how negative? 8 times negative 2 is negative 16. Negative 16 plus 12, because 16 is bigger than 12, you're not going to get past 0, so it's still going to be negative. That's why on this problem, I'm going to lean toward the side of the problem that has less stuff inside the log, because it's going to be easier to check that side. So positive 2 times a negative number is going to be negative. That's bad. So if negative 2 doesn't work, the answer must be no solution. I think that's it. Did we answer all of the questions? Yes. Ta-da!